Morning, everyone. Welcome to SIG-Apps. Today we have a full agenda and we'll probably use the hour. So I know the meetings have been 30 minutes so far. We decided last week to change them to an hour. And today we're going to discuss a few things. There was a doodle that was sent out to figure out what the new meeting time on Monday will be. So I'll let Matt talk about that in a second. And then KPM folks are here, Quentin and Antoine, right? And they're going to do a demo of KPM, some upgrades there, and then we'll go through the proposed work for SIG-Apps doc, and we'll just go through that kind of from top to bottom. If you put an item on there, we'll discuss it. We'll talk about the needs and the requirements, and we'll solicit help. So before we get started, do we have someone who would want to volunteer to take minutes and write down action items for this meeting? Okay, awesome. Thanks, Vic. Do you have the doc with the minutes? No. Okay, that's okay. I'll give it to you. Here you go. All right, thank you. Okay, so Matt Farina, do you want to announce the results? Thanks.
So the time that appeared to work best for the most folks on Monday is 9 a.m. Pacific time, 12 Eastern, noon Eastern time. And so we'll be shifting over to that time slot that had more folks who could make it than any other time slot and appears to overlap. It's a little early for the Pacific folks and a little late for the European folks, and so I hope that's a time that everyone can make. And if I understand it right, Michelle, you control the invite, and so we'll be updating the invite, and so we'll meet again in a little less than a week, which is next Monday.
So if you couldn't get enough of SIG-Apps before, you get a double dose this week.
Yeah. Are there any questions about this time or anything about it? We'll still be recording anything if you miss it and all those good things. Are there any questions or comments on this?
Okay, great. Let's see. So yeah, I will change the calendar invite right after this meeting. If you want an invite to your email account, message me on Slack. I'm Nurali. Okay, and without further ado, KPM, do you want to take it away?
Sure. Can you hear me clearly? That's fine. Okay, cool. Okay, so my name is Quentin. I'm working at CoreOS. I'm the maintainer of Claire, a security analyzer for Docker and AppC images. And over the past few months, I've been working on Stackanetes, which is an initiative to bring OpenStack on Kubernetes. So the last months, I've been working on re-implementing Stackanetes with KPM instead of for kind of bad Python tool. And that's what I'm going to show you today. So let me share my screen. All right, I believe you can see my screen now. Can you? Okay. All right, so I will show you a bit of the architecture of OpenStack with KPM first, and then I will show you around some features that we have. And finally, I will do some update stories real quick. So here I have my local clone of Stackanetes. So feel free to interrupt me with any question that you may have anytime. So here I have my local clone of Stackanetes. You can see a bunch of subfolders. We have, for instance, Cedar, Elasticsearch, Glance, Horizon, MariaDB. Some of the names might be familiar for you. These are all pretty independent packages that we can deploy on Kubernetes. So let's see how they look like, right? So, for instance, Glance, we have a manifest, and we have a bunch of templates. So the manifest contains some metadata, such as the name, maintainer, version, license. We then have some variables right here. And finally, at the bottom, we have some declarations for resources. So I declare a few config maps, and then I will declare some jobs. I declare some deployment, services, etc. And then finally, of course, we have the Kubernetes manifest, which pretty much look like any other Kubernetes manifest. It's in Jinja, so we can do variable replacements. It's not the only expander that is available. We could like use different engines to process these files. So we can find here, for instance, deployment.image.registry that was available in our manifest initially, right? Deployment image registry. The manifest itself is in JSON.NET. It's very powerful. We can do very, very fancy stuff. I will show you some of the things that we do. So they all look like this, and they all can be deployed independently of each other's. And finally, we have Stackanetes meta package, which is simply a package that says, well, to deploy OpenStack, you have to deploy all the services, right? You have to deploy MariaDB, RabbitMQ, Memcached, Elasticsearch, Keystone Cleanse, etc., etc. And we have a parameter file right here, which contains all the configuration for OpenStack, basically. We have the number of replicas, we have the labels to deploy your stuff, the path to get the images, some network informations, DNS servers, etc. Safe configuration right here. We have feature flags, and that's pretty interesting, actually. Here I disabled safe, as well as disabling the ingress. Oh no, it's actually enabled, sorry, my bad, but anyways, it's feature flags, right? And what's cool is that with JSON.NET, we can do fancy things like, well, if ingress is not enabled, then you should not deploy traffic. Or if Ceph is enabled, then you can deploy Cinder, right? Everything follows here. Okay, so after I wrote all these packages for each independent service, we have to push these packages to a registry. So that registry can be either your private registry, or it can be like the kind of official KPM registry. It works basically like Docker registries, right? It's the same principle. Okay, so once we have written all these, we can actually, and push the packages, we can actually deploy everything. So I did it a bit earlier today because it takes like a few minutes and I didn't want to bother anyone who is waiting. So I deployed OpenStack with a single command that we have here. KPM deploy, right? Then we have the namespace and the meta package name right here that I showed you a bit before. We have the registry address. Here I'm using a local registry. I mean, it's a registry that is deployed in Kubernetes. And I pass a custom parameter file to override a bunch of variables. And after a few minutes, KPM will actually resolve all the dependencies and update my Kubernetes. So everything gets created here because I had nothing before, right? So we can see that it created MariaDB config maps, deployment service, RabbitMQ, etc., etc. So it's a lot of things that we are actually deploying to get OpenStack running. It takes, at the end we have a summary. At the end, it takes like 3 minutes, 30 seconds, right, to actually push everything to Kubernetes, and then it takes like 2 more minutes for everything to get started on my cluster. So this Kubernetes cluster is actually a hybrid cluster. I'm using at the same time Rocket and Docker. So I have a few nodes with Docker, and I have a few nodes running Rocket. So that's one of the things I've been working on, actually getting OpenStack running on Rocket. And at the end of the day, well, we can access OpenStack. I think that's it. Yeah. From an external standpoint, this is running outside of my Kubernetes cluster, and I can log in Horizon. I don't know if anyone is familiar with OpenStack at all. So we have like the whole thing, right? We have Open vSwitch running on top of Kubernetes. So I have an overlay network. I have here my external network. I have a virtual router. I have a private tenant network here. And I also have VMs actually running on OpenStack on Kubernetes. So here I have a pretty fancy VM running actually. It has 2 IP addresses plus an IP on my external network. I also have a volume attached to it. So this is a set volume. We have a console. This basically everything you can hope with OpenStack. My console is empty right now. Yeah, here we go. So yeah, that's what we get at the end of the day in basically 5 minutes, which is a great improvement compared to the amount of time it usually takes to get OpenStack running. We can also do pretty fancy stuff. So let me create. So I can also access all the APIs using the command line. So this machine here, where my cluster is not part of the Kubernetes cluster. It's running outside of it, right? So I can import my OpenStack environment file, which contains all like my logins, passwords, etc. So I can use OpenStack from the command line. It's all using ingress resources, which again can be disabled or enabled. So let me create a new VM. Which should not take more than a few seconds. All right. Let's get it spawned. After this small thing, I'm gonna show you what other things we can do with KPM. Okay, and then we can actually live migrate that VM onto another Kubernetes host. So it's currently running on the host B13, which is part of my Kubernetes cluster, and can simply just like this, go for it. Well, and after only a few seconds, I will have migrated my VM, which is running on Kubernetes, to another Kubernetes node, which is pretty useful to join Kubernetes nodes, for instance. See, this VM got migrated to another Kubernetes node. So if I execute kubectl join some node, it will migrate all the instances automatically as well. No, that's not everything we can do with KPM, right? Because deploying is only part of the story. The real challenge with OpenStack is actually updating it, and that's something that KPM provides us pretty easily. So let's say we can do all kind of stuff, but we can say, for instance, I would like to add some Ceph node. Just have to modify my configuration file. I may as well modify some Horizon deployments. I don't know exactly what I would like to do here. But I don't know, what can I modify? I modify silly things. That's it. And then to actually update my OpenStack cluster, it's quite simple actually. So I have to push my modified packages. I modified 2 packages here. I modified only one. I modified Horizon, and I modified my configuration file. So to update Horizon, I first need to push it, right? So I use this command. Well, okay. CD horizon, kpm push. I have to specify my registry, kpm registry .kpm, and force. Force is here because best practice when I upgrade the package will actually be to bump that version number, right? But I didn't do it. With kpm, you can track channels like alpha, beta, stable, but also version numbers. But here, because I'm just in the development mode, I just push it with the same version. It doesn't really matter. And I can simply redeploy it, right? Like if I press enter right now, which is the exact same command I used before, kpm is just gonna figure out what did I change exactly and what need to be changed in my cluster. I can also deploy a single component like this, which is again one of the packages, independent package, kinda. So it didn't modify the first config maps, but we can see that it actually modified the deployment, which is what we expected. Because I also modified some safe parameter, I can redeploy Nova, and it's gonna update appropriate things as well. So kpm can trigger rolling upgrades and all this kind of stuff. In the future, you will also be able to set which update method you want if you would like to replace or simply drop, etc. There we go. So yeah, that's about it, I guess. I went pretty fast. I showed a bunch of stuff. I'm not sure what you might be more interested in, or if you have any questions.
All right, thank you. Do we have any questions about this?
All right.
Okay, go ahead, Michelle.
Yeah, thanks. Thanks for that. Okay, so if there are no more questions, then we'll go on to printing this document. Let me share it. Would you mind letting me share a screen? Okay. All right, so let's go ahead and go through this document, and I'll just call out the heading, and we can, whoever put this on here can and talk more in depth about it. So the first one, which was the first thing that that we started SIG-Apps with, was Petsets. So Clayton, do you want to talk about that?
Sure, and I don't think Prashant is on the call. We have Eric as well. So Eric and I were talking a little bit about this. There was a desire to bring Petsets to beta in 5, and we were trying to figure out what that would be. So one of the goals would be get to the point where we can agree that Petsets solve the problem that we're intending them to solve, and that we understand the scope of work necessary to fully solve those problems. The core case here is getting use cases and getting examples that gives us enough info, and then making sure we all agree. And I don't know that we need to go into all the details here, but as part of this, we've been trying to work through this. So I guess a useful question here is, do people generally agree or generally disagree that this is a good goal? Are there people who are going to commit to spending time on working on this? And are there any aspects of this that we might be missing? Like, that's kind of a useful thing to help filter out to find the list of things we're going to do for 1.5.
Okay, great. So what was your first question again?
So does anybody have any disagreement that this is a generally useful thing for SIG-Apps in general? Which would be, we don't necessarily have to kick things out of this list because not everybody agrees that they're useful, but it's good to get discussion on whether people agree that this is something that's important for the SIG in general.
Okay, do we have thoughts on that?
I'll jump in real quick. This is Matt. I think Petsets is important. The whole, the ability to handle stateful applications is, we're just at that place where we've got to deal with it. And Petsets looks viable, and I hope we can test it out.
Yeah, I can speak from the charts perspective. We've had one chart that didn't use Petsets be contributed so far. And I think that talks to the need for this feature. I think we're in a little bit of a chicken and egg problem here because we need people to start using it and depending on it and saying that it's good for the full life cycle of applications, being not just it can install, but you can upgrade it. You feel comfortable that the life cycle of your application is handled. But we're also calling it alpha and incubator and all these things that make you definitely not want to put your mission critical data into it and then have to treat it that way. So I don't know how we fix that, but I do think it's important to get the feature out there and at least more than alpha.
So, and that's actually a really good, so that flushes out one of the important questions to ask is, would I run a pet set in production, and how do I get the confidence to say I would run a pet set in production? So the kind of rule of thumb that Eric and Prashant and I had discussed last week was, it doesn't eat my data. And so what are the things that we as a SIG and as the people working on this need to do in order to ensure that it's not going to eat my data?
One thing that could be useful is a don't delete like a PVC at all flag, that we could allow people to just kind of manage the PVC lifecycle on their own, such that worst case, some bug they hit, they at least still have the PVC around that they can patch.
It actually shouldn't delete the PVC. If it is, I would say that's a bug.
Okay. Cool.
But the other things would be like inducing split brain, making it easy for someone who's writing something that depends on split brain not happening to understand how to avoid split brain.
Yeah.
I think there's two parts to the goal is to build trust that Kubernetes is a place where you can run stateful apps and you don't lose your data. So the two parts of that are that Petsets is a building block that when used properly does the good things that you just said. It's going to be pretty hard to make it, stupid proof. So we shouldn't try to do that. The second aspect of that is that there's a collection of quality charts and examples of how to use Petset in a way that you don't shoot yourself in the foot. And so I see us building those two capabilities out in parallel. And charts is that second thing.
Yeah, one thing that
it didn't make any sense, or people are odd about how clear that is.
That makes sense.
Yeah.
But how do you build that trust is the real question. I think having the examples that are easily installable is one part. The other part I think is actually having functional testing for the charts inside of the Kubernetes charts repository or whatever to show that the lifecycle actions actually work continually. I think will be pretty important, and that's something that I'd love to tackle over the next few months, is to get that stuff nailed so that we're testing more than just install and remove. We're testing the upgrade cycles and all that stuff, and we feel really comfortable with where Petset's at.
That's awesome and super important, Vic. Thanks.
And another useful question too would be, are we stressing the examples enough? So a great example would be someone writes a Zookeeper pet set. Who is skilled and familiar enough to say, this Zookeeper cluster will not suffer split brain because I understand exactly how Zookeeper works. What are the test matrices and tests, like to extend upon the testing? Like, what other work do we need to do in Kube to enable people to test? Like, do we need something like Jepsen? Do we need something that puts the ringer? What we've done functional testing in this manner for a lot of Kube items, but we've never really extended it all the way to this other thing running on Kube is provably correct, or at least we can get within that realm of certainty.
I think it would be useful to figure out if we could get a subject matter expert for each of the things, maybe choose a handful, 5 or less applications that we need to have a SME who's like, run Zookeeper in production, run Cassandra in production for a long time and knows what that, benchmark should be and can define it. And maybe, because I would feel comfortable kind of orchestrating the testing and making sure that the testing is running all the time, but actually creating the tests, I'd feel less comfortable on the ones that I don't have as much experience, right? So having someone who can set that bar and, has a experience in what those things should look like in production and when they fail, right? Because each of them, like you said, has a different failure mode that is extra thorny for it. So figuring out the person or persons that will be the test plan creators, I think would be important.
Maybe also finding subject matter experts. And so then there's a couple of the subtle things here where do Petsets actually solve enough of the problems, right? Cluster management, things like pacemaker. There's a number of problems that have been identified, getting investment on that. So it sounds like everybody's kind of on board in the first one. We need to discuss more about what the actual plan is. The second question would be, who is involved, who's willing to pony up to contribute to this. So getting a list of people who are actively going to work on this because they also agree it's important. We don't have to do that in a high level here, but just calling it out so that we know what, if no one is interested in something, then it's kind of a burden on the person who proposed it to try and convince people to spend their precious time on it.
Yeah, agreed. I think it'd be fine to ask here if anyone is interested, and this is the place to organize. So is anyone interested in committing some time to this? I know that Lachlan and some other folks have contributed charts. Do we have any other people who want to continue working on this and spending some time on this from this group? I'm taking typing as not so much. Okay, I'll send this out we'll kind of solicit people in the mailing list as well, since not everybody's on here.
Michelle, I think it would be good to break out the type of work that it would be. I'm happy to help, but if it's hardcore Go programming, I'm probably not going to be the best person to do that. Just to figure out what skill sets you would need in order to contribute.
Gotcha. Okay, cool.
I'll write down the folks I know of on this one.
I'll work with you on that, Clayton.
Okay, thanks. Okay, I think that's all for Petsets then.
Okay, great. So on the matter of Helm, I guess I'll talk a little bit about that. And Vic, you're welcome to jump in, and whoever else. But as for the Kubernetes charts repository, since we've been talking about that anyway, some of the things that we're working on here is setting up the official incubator process. So right now you would contribute a chart to the incubator, and then there would be some requirements to get into the stable or the official charts directory. And Vic is currently setting up a CI for that repo, and we're also trying to get more charts. Vic, do you want to add some stuff around this?
Yeah, so some of the stuff that I'm working on right now is basically figuring out the release process. So getting the existing charts, we've gotten a handful of charts now, figuring out the release process, getting the repos kind of set up for continuous releases when things get merged to master. And also fleshing out the contribution model, right? Like what is our bar for things to get in there? What are things that we're looking for in certain charts? And hopefully as we go through these, we can start to flesh those out and create a document as we go that tells people the things that we're going to be looking for to merge. And then once that kind of contribution process is a little bit more nailed down, figuring out a little bit harsher CI, I guess, more functional testing than what we have today. Today it's wired up and we can add a bunch of stuff, but it's really just doing lint at this point. So adding the rest of the functional testing will be next after that.
And what would be like from this SIG? I think this SIG is a great place to talk about the contribution process as it evolves, since I'd imagine these are the people who are making applications and submitting them. So what else would be like from this big SIG specifically during the setup process?
Really, it's like getting best practices for, what Kubernetes manifest should look like, right? Things are popping up now, like being able to always configure memory and CPU was popped up over the weekend. Just whatever best practices you you have for your charts should bubble up into our process for the charts repo. And I think Chris opened a bug to get both the Docker file best practices and Kubernetes and Helm best practices tickets or readmes open. So once we have those, feel free to just send a PR that says, hey, we should also look for this. And then as charts maintainers, we can just go down a list and say, yes, it meets all of this. And contributors can be confident that they're doing all the right things.
And then just to add, one of the things that I've been trying to figure out over the last week or so is trying to figure out how to put a testing framework inside of a chart to actually test the chart. So I might have something tomorrow or the next day to show on that.
Super interested to see that when it's ready.
Yeah. So on the topic of the Helm project, we're trying to get Helm from alpha to beta status. So we just released alpha 4. Let me I have the release notes here somewhere that I'll paste in a minute. But yeah, we basically have a roadmap here. We just have a few more features to add. From this SIG, I'd like to see more people going to Helm, going through the documentation. We want to make sure that it's really clear what's going on, that all the examples are correct and legitimate. I think they are, but we just want double checks. If you want to contribute to Helm, we added this starter label. So if you haven't worked with Helm before and you want to get your hands dirty, then that's the place to go. But really, getting more charts is the main goal here as we're moving towards beta. Okay, do we have any questions on that? Okay. Who wants to talk about templates in Kubernetes?
Sorry, scrambling to unmute. So there is discussion about this, which was moving forward on the templating work to get a stake in the ground. There's a little bit of interest from a number of different people at this point. So in general, the templates sit at a slightly different space than Helm. We have the approved proposal in the Kube repo. I think there's Google and Red Hat certainly had interest in seeing it through to conclusion so that we had a lower level tool that could be consumed by higher level things like charts and other frameworks. I think in the question of SIG, does anyone here object to this? Does anyone here have a strong vote for or against? We went through a lot of discussions originally in templates, in Helm charts, and where Helm charts and templates differ, and how other config languages like the JSONet stuff being used fit in. It's probably the role of this SIG to help kind of absorb all the lessons from before and create a path forward.
Clayton, can you give a 20-second overview of what kind of templating we're talking about here?
So this is the approved proposal in the Kubernetes SIG. The template is a structured JSON object that is a valid Kube API object that supports only limited string replacement and has explicit parameterization for the purposes of presenting the simplest possible replacement mechanism for API objects. So for instance, something that might be represented by a fairly large and sophisticated JSONet or Jinja or Helm template is not necessarily the same thing as an API object you can store on the API server that does very simple templatization. And the use cases for this are generally, they do sit in the same space as charts. And I think one of the challenges so far has been this work, what goes in core Kube in order to support extension of core objects. Kube will never pick an authoritative templating language, or won't for a very long time. The in-between space of having something that allows you to do quick and dirty templating is enough of an 80-20% solution that there's the proposal to have it in as a core Kube object.
Clayton, did you notice that Helm charts can have the possibility to change the templating engine? And would you be satisfied if they had a simpler, if you could use a simpler templating engine like the one in the proposal and restrict your users to that engine rather than Golang templates?
I think there's a whole host of issues around that. I actually think if we're going to get into a deep discussion of that, we should get Brian in as well. Because I think some of the original goals for templates are somewhat met by Helm, and I think some of the simpler outcomes can be done more effectively. So why don't we come back to this and say we need to have a discussion on with Brian and some of the other proponents of templates available, and we can talk through, how that would fit in with Helm, because the discussion certainly has evolved since the proposal was merged. Does everybody agree with that? Any disagreements, concerns?
No, that makes sense.
Nope.
Okay.
Yeah.
All right, well, we'll move on to the next one then.
Good. Examples and improvements to using config maps for real apps. Who put this one in?
So this was Brian put this in, and it was part of some of the ongoing work that's being tracked. So I can speak a little bit to this. There is a general desire to make use of config maps, to have config described in the Kubernetes system. So you can, once you've created a config, you can reference it from a number of spots like deployments, pods, Damon Sets, Petsets. The challenge with that, and there's a couple of them. One, during rolling deployments, you need something that takes into account the fact that if you roll forward, you change your config and then roll forward, if your config breaks your app, you can break your entire app all at once. And then if pods got deleted or recreated, you might end up with a non-working application. So having some way to test or to involve config maps in the lifecycle of a deployment is the first issue. The template object for in-container configuration files is a long discussion that is generally boils down to it would be good to have examples, documentation, and affordances that make it easy to templatize config maps when you use them. And we have a number of existing patterns in place. And so the discussion really is driving this to conclusion, learning from the use cases, and prioritizing any small amount of work that makes it easier to take a config map that isn't just config, but might represent a template for a config, and allowing the platform to be able to transform that and do that at runtime. Downward API is a big part of templating because it's how we inject environment specific settings into pods. The all-in-one managed data volume, actually don't know which one that is.
That is the volume that can project secrets, config map, and downward API information into a single volume.
Okay. And that's the flexibility aspect. So we have downward API so that you can do injection of things, but there's some limitations today. Paul, do you want to talk a little bit more about what this does for end users?
Yeah, so currently we have different plugins for config map, downward API, and secrets. And what that means is that you can get those things projected into volumes, but they're different directories. So there's a number of use cases where a user wants to put all of those things in the same directory, and we don't really have a great way to do that right now. There is a subpath that was added to the volume mount API, which it can give you, in certain circumstances, give you that, but it's not a full solution. In part because the kernel bind mounts inodes and not symbolic links. So the content of a config map directory, for example, or config map volume, for example, is symlinks into another part of the same volume that holds the actual content. And the reason for this is that it's necessary to support atomic update. So if we had a volume that could project all of those things into a single volume, it would get around some of the usability issues there. And this kind of dovetails into the next thing on this list. Any questions?
Paul and Clay, can we pop this up one level and maybe say hey, who's had to write a chart that has a config file that's part of what's deployed in the Docker image and wanted to edit values in that config file, and maybe do that post deployment to adjust the app in the chart. How did that work? What sucked about it? What features did you need? We think these might be the list of features you need to make that easier.
Yeah, I think that's fair. The next one on the list is also in that same vein, Eric. I don't know if you want to hear about it now or not.
This is kind of like pushing up a list of things that a bunch of us who have worked with this a lot think we need, but we do need to also kind of say, hey, people who have been really writing charts, what have you wished you had? What are the messiest parts of your charts? We need to have a show and tell about that and see if these things line up.
Yeah, I think the scope, though, is wider than just folks that are writing charts. I think this is sort of a general usability issue for like managed data volumes. Whether you're writing a chart or you're just trying to get your thing to work. So I would only ask that we expand the discussion beyond just the folks that have been writing charts.
Yeah, so I'll note that call to action there. So it sounds like there's a number of committed folks on these items. Does anybody from the SIG have a question about the general place of this in the Cube ecosystem, or whether this is appropriate for the SIG or not?
I think this fits well in SIG, and I think we should have a sharp edges of Kubernetes resources or Kubernetes deployment or application deployment, like doc or something, and say, hey, I had to do this nasty hack, and it's just like something that we can all add. You know, we've all hit some stupid thing that you had to do in a Docker image and then do another weird thing within a init container. I did this last week. So I think if we started a doc and sent it around, like add your sharp edges and point to a GitHub repo where you show what you had to do to get around it, then we could start to get an idea of what these things look like in practice.
I think that's an excellent suggestion.
Yeah.
Okay, is that something that you guys will take a note?
Yeah.
Great. Brian added the next one. So anything else on config maps for real apps? Maybe we should just rename this, which is using config within real apps on Cube, config maps, secrets, injected config, templates, and downwards. Templating of config and downward API. So any other comments on that one? Okay, so the next one was a request from Brian, just a general call to action that we need a significant amount of investment in making Cube apply work correctly. And so this is kind of a request from, this is all supposed to work, but there's a number of outstanding goals and looking for people to help commit to driving some of these features to conclusion. So in general, declarative config is the idea that you deploy a Cube cluster, and then instead of having complicated mechanisms where you go iteratively change using scripting, you redeploy or reapply your config. This is something that both DM, deployment manager, and Cube control apply depend on. And this is kind of a general pattern of you apply your config again, and then new things should just work. So is there any questions on kind of the high level that I do a good job of explaining what it is and why it's relevant to the SIG?
What is the actual issue with kubectl apply though?
The umbrella issue is that there's a number of edge cases, bugs, implications, wrinkles to flesh out Cube control apply to more fully solve the problem.
Okay. Yeah, I think this fits with the SIG. We've had someone who, I think Mike, has contributed to kubectl, so, and it makes sense for it to be here as well.
Yeah, I see a couple of participants on the discussion issue. I know Sam from Box is invested in this. So on this one, I think maybe the question to the SIG is there anybody else who depends on this for their workflow that's willing to pony up resources to help? And so we just add those in here as well.
Does updating a chart use an apply workflow or an apply-like workflow?
It does. It uses that strategic patch library. It does exactly the same thing. So I would be interested in how this pans out. And I can be a part of that conversation as well.
Damon Sets. There was a question about identifying charts that use Daemon Sets. Are we aware of any at the current time? Eric, is this your issue?
I did type in Damon Set. I don't remember adding charts that use them.
I think Brian came through and added something. I don't know if someone else came in and added a comment on this.
Yeah.
Vic, have you seen any charts that use Damon Sets yet?
No, none yet.
I thought that the Cassandra chart did. Has that been submitted?
We don't have a Cassandra chart submitted to the Kubernetes charts repo right now.
Okay, I can ask
Chris's work, yeah, he hasn't contributed that yet.
Okay.
Yeah, I think the call to action here too is this is a little bit like the config maps for real apps, which is the sharp edges interviews with app authors and get people who are committed. So I know of a number of these in use, a number of Daemon Sets in use in general for production applications, both system monitoring type activities as well as a way to get stability of identity prior to Petsets being available.
Mm-hmm.
The rolling update feature is listed on the roadmap, and I think that was the example there. We don't have a general pattern in place to update things other than deployments. So kube control apply on a Daemon set works, but it doesn't do exactly what you would expect. And so I think both this Petsets, because we had this listed under Petsets, needs the discussion of how do you run an upgrade on this and how does that fit into the apply strategy.
The canonical example for Damon Set is supposed to be HDFS on bare metal. So I would think it'd be great if we had someone who knows HDFS wrote an HDFS chart that used Damon Set, tried to work through some of the upgrade issues, and then gave feedback on that didn't work.
So I have a kind of higher level question. Do we have a precedent from this SIG or others on how we get this kind of feedback? Like hey, operators, you're out there. We need your feedback to make this better. How does that work in the past?
Go ahead, Michelle.
Most of the time, Clayton wrangles people up, wrangles people to help give demos and stuff. And then a lot of the time I just tweet about what we're going to talk about and end up getting a lot of DMs or replies like, hey, we can demo this thing. So it's been a lot of that.
Okay.
And I'd say in practice, like a lot of the early work on this was getting feedback from early adopters of Kube who were very involved in the development process of Kube. As we started to broaden out, like we definitely need to be able to draw people in who are using Kube as naive users and identify gaps in either what the capabilities we have that people aren't using as well as the capabilities we don't have. So an example for Damon Set would be if there's no canonical example for Damon Set for someone to pull from for HDFS or for a real example, how will people know what to go do? And will they know all the implications? Do we have good enough doc? And then the next question is once they do that, is it even useful? And this is a little bit like Petset as well.
Yeah.
So there is, I guess there's the HDFS example. I think we would want to, I'll get the Gluster guys. So Gluster has built a productized Gluster on top of Kube /OpenShift using Daemon Sets where it has cluster integration. I'll have them try to articulate that, and we'll get them here to talk about what their challenges are. Admittedly, they're not the most sophisticated Kube users. They're much more sophisticated Gluster users, and so they might fit more into that first category we mentioned of someone who knows the domain but doesn't know Daemon Sets versus someone who knows Daemon Sets and can represent the failures in excruciating detail.
I think it's useful to have both.
Yeah, absolutely.
We can also reach out to the Kubernetes users group and see who has used Daemon Sets. They might also consist of some more naive users or a mix of users.
And so as far as committing, I would like to dovetail the discussion on Petset updates with Daemon Set updates, at least to make sure that we have parity for our first non-deployment updatable resource that has to represent state. So anyone who is who's going to be involved in the design development side of that, it sounds like that's a proposal. Prashant will probably own the rolling update side because he's been doing that so far. And then maybe after we should dovetail Damon Set discussion into that proposal. Does that make sense?
Yeah.
Okay.
Job improvements.
Yeah. Eric, is this you?
Yes. If anyone used job and wished it did something different, speak up. We'll probably have someone work on it. So it doesn't make an infinite number of pods if your job has no hope of succeeding.
We should probably tie that into deployment improvements as well, because deployments has permanent deployments.
Well, I mean, job is different because jobs are expected to exit and then retry, so they make infinite pods. Deployments tries to make a finite number of pods.
But deployments can permanently fail. Maybe we can take it offline. Okay, so I don't know of no one has mentioned to me job requests. I think there's the larger job discussion of people who want to build more complex job frameworks on top of Cube and reuse primitives. I know there's a number of people interested in that, but I'm not aware of any work ongoing right now for that. Eric, is that something you're aware of, or anybody else on the SIG call?
Yeah.
Eric, is the DAG stuff still continuing? I haven't heard about that in a while.
Hasn't been much talk about that lately.
Okay, so we definitely got the agreement to do it as a third-party resource, but then we haven't come back to it then.
Somebody else built something, and I guess the person that really wanted is using that other thing. So.
Okay. All right, so we can ignore that for now, I guess. Anything else on job improvements?
No.
Nope.
Okay. So in deployment improvements, I don't see McCall. McCullis is on. McCullis, do you want to talk about this?
Can you hear me?
Yeah.
Yeah, so we are working on a couple of updates for deployments. The roadmap lists most of them. We found out that we need to, all of the controllers, like deployments, jobs, Petsets, or whatever, to list valuable info for in case of failures for end users. And that's let me link. There's an ongoing pull request, term failed, and I would love to have some feedback on it about failures for deployments, like Clayton mentioned.
And yeah, one of the big usability, just to summarize this so people are aware, one of the big usability bits of feedback we've had from controller type concepts in general is that it's very difficult to build UIs that clearly indicate in summary or list views when something has gone terribly wrong. And so as soon as you start bringing in things like quota, which you can run out of quota and the controller can't create more stuff, you can bring, you can add limit ranges that prevent a pod from being deployed. You can add pod security policy that prevents a pod from being deployed. Because that happens when the replication controller or replica set goes to create it, it generates events, but not everything everywhere in the UI can correlate events. And so it's very difficult to actually build UIs that communicate to users clearly and distinctly when the controller is utterly and totally borked. And so one of the points of discussion from a usability perspective is, can we do a better job of rolling up summary status by controllers?
Yeah,
So,
I guess it all starts from Kubernetes, right? I mean, we have to make sure that each level surfaces all those information clearly, so other layers can clearly lay on top.
Exactly. So that you can build the simple UI that says, "Hey, is my deployment failed?" And the deployment would say, I can't make progress right now, and you can go get more details by looking at the replication controller or events. But
this also is related to replica sets improvements. The next point that some of those failures there are like events in replica sets, but I guess there is a need for status like conditions on replica sets and replication control, so those information can be surfaced more clearly.
I think charts is an interesting case because a chart can have many resources that are its children, and like a control, or like the same way that a replica set has pods that are its children, and you want to roll pod status up to the replica set, you want to roll all the status of all the children of a chart up to that chart, but the chart's UI is not kubectl. So when you think about how you roll summary information up to objects that are not completely in the Kubi ecosystem, which is fine, but how does that work?
Yeah, and how do you correlate those? So that gets a little bit into the app controller stuff and some of the other discussions of, in general, if you cannot summarize a set of things to an end user, the end user will not understand what's happening, which means the end user probably considers the platform a failure. So this may be just a general topic that we should consider maybe a proposal or have a working group session on in the AppSig to discuss roll up and all that.
Yeah, that sounds good.
I'll make a note of that.
We only have a minute left. So is it all right if we go ahead and wrap up?
Yeah, I think so. We can always do this next week.
Yeah, let's continue this discussion next week. And then until then, we can act on the action items. Okay, does anybody have any last minute things to add? Okay, thanks so much. And I'll see you next week.